Hey Guildies, Fletch here. Today we're going to talk a little bit about unit testing, and we're going to go through some unit tests, and we're going to show, this is some things that you can test, and then these are the things that you sort of don't have to test, like at least not unit testing wise. We're going to say, this is what a test looks like, this is what a test should not look like. So let me just open some things up and get a project started. This is like a made-up user story, for example. So we have story one, estimate prospective income. It's just sort of a thing that I knew had some logic in it. It has some functional programming in it, doing some sort of calculations. And this is sort of the way that we do it at our company, but not really. It's just sort of a copy, but also made up for testing. So as a hiring manager, I want to provide employees and contractors with insight on prospective income. So if I'm hiring somebody, then I want to be able to say, this is what you would make after working with us for a year. And everybody, at least with my company, gets paid 1099 hourly rates. So this is all related to sort of what kind of, if you made this kind of rate, what you'd make at the end of the year. And so we're going to make a little bit of some code that does that sort of thing. So acceptance criteria, if I've got a new employee or contractor, and whenever I consider the client rate, that is the rate that we're charging to a client who's receiving the work here, and we have to consider the completion withholding. That is like at the end of a project, you sort of hold back some money, and then at the end of the project you say, okay, yeah, everything looks good, here's the last 10% or something like that. And benefits, so if you're a company that's providing healthcare benefits or retirement benefits or anything like that, then you'd be removing those from a paycheck, for example. So when I consider those things, then I can estimate what their weekly pay would be and what their end of year withholding return would be, so that with that withholding that you get, what you would get back for any given year. So that's the acceptance criteria. This is super basic. I'm not trying to focus on how to make a user story or anything like that. If so, this wouldn't be the example necessarily, but let me show some of these details. I'm not going to get super deep. I'm not trying to get people to understand how payroll works or how our payroll works. And if they wanted to know that, they wouldn't be watching this talk, that's for sure. But we got some basic stuff down here. So rate calculation. If we're paying the client, let's say like $100 an hour, that's the hourly, not paying, we're charging the client $100 an hour, and we're withholding something from what we pass along to our contractors, we're withholding, let's say like 10% from them, then we could figure out that the contractor's rate for that client is just like an inverse. So like if we're withholding 10%, that means we're paying you 90%. That's the opposite of that. So if we're charging a client $100 an hour, then we're paying a contractor $90 an hour. Not real numbers, it's just really easy to do math on, so I'm just throwing that out there. So that's one type of calculation. We don't have to memorize this, it's here for reference. Weekly pay calculation. So at the end of each week, we would be billing, let's say like 40 hours at the end of the week. If it's more than that, then overtime, we're going to do overtime times 2. So however many hours are over 40, we're going to just double it. It's going to be double time. So we've got the hours, the doubled overtime, and then we're going to multiply that by that rate that we calculated up here, that rate that we're going to be paying to our contractors, which has a little bit of withholding in it. So we've got the weekly pay calculation, but as part of the weekly pay calculation, we also have to consider their benefits. So like if their benefits are $1,000 a month, for example, and there's 4 weeks in the month, then we'd be withholding $250 from each paycheck. So the weekly benefits is just whatever their monthly benefits is divided by however many weeks there are in that month. And then their weekly pay is the sum of all of the client pay that they got. So all the work that they did, they're getting money from the client. And then we're just going to subtract that $250 of benefits that has been broken down by week. So this is just some example stuff for weekly pay calculation. This calculates how we are going to return back the money, like at the end of the year or the end of the project, how we're going to return back all the stuff we withheld, say, okay, this is a good job, we're all in good standing, and so here's that 10% back that we withheld throughout the year, which, $10,000, $20,000, whatever the case that ends up being. This will calculate how we're going to return that to them. And then lastly, we're going to use these calculations, and we're going to say, well, what would we estimate? We're not going to use these calculations in real time every week. We're just going to say, given a standard 52-week year, let's say for 2023, and we want to choose a specific year because depending on the year, different months have different week numbers in them. Sometimes January has 4 weeks in it, sometimes it has 5 weeks in it, or sometimes it has 4 Saturdays in it, sometimes it has 5 Saturdays in it. That's how we calculate weeks. So let's just take that generalization of 52 weeks in a year for any given year, and let's use all these calculations and say, well, what would you expect to get by the end of the year? So we're going to go ahead and do some coding here and fulfill these things. So task 1 is just API development. Do some API development, and here's like the contract right here. We're not to this point yet, but I'll just show you because it's the last part of the piece of paper here. So we're expecting that whenever they return that estimation, we'll see whatever their total paid is at the end of the year, like what essentially their salary, what the end of the year money is, how much total they withheld from their benefits, healthcare and whatnot, and a list of all 52 paychecks. The very last paycheck will have 2 line items in it. It'll have whatever the line item is for that week of work, and then an additional line item for the return of that withholding. So in this case, they were returned $25,000, end of the year bonus for being in good standing or completing the contract or completing the project. Okay, so let's jump in here and do a little bit of this programming. I'm going to call this payroll, and I can spell. And this is just a super basic. Why did it open the Git ignore? I swear I clicked on. Oh, there it is. Okay, so just super basic, just calling .NET New and just creating some solutions and projects here with the names that I want. So we've got payroll here, and it's got some projects in it. So let's go ahead and open this up and take a look at what we've got. Okay, so super basic, just basic web API. You'll notice it has like the weather forecast in it and stuff like that. I'm just going to be a little bit particular and edit some of these things. I'm going to be putting in treat warnings as errors and also a general namespace. It's just the way they like to do general namespace. I just realized that I'm not sharing my screen. Can't see the screen. Thank you, my new brain. Let me do, bam. Okay, so let me just show this other thing. I ran this create API script. I did, it just does .NET create some projects and solutions, and it does these things. And while I was talking, I'll go ahead and bring the pulse back on the screen. Thank you for telling me that you couldn't see it. So we've got the story. That was weird. We've got the acceptance criteria, and we've got these calculations. And I put these on the screen so that people can see them for later on. If they want to pause the video and double check my work, essentially. Okay, so we've created this using that script that I had. We've opened up the payroll, and I am putting in these treat warnings as errors and these root namespaces right here. So there we go. It is not copied anymore. Copy, paste. There we go. And then one more. And for some reason, this is in the wrong spot. There we go. Okay, so we've created this project. I'm gonna now just delete out this built-in weather forecast code. Let's call it health check controller. Yeah, sure. And this is not a tutorial on how to build a web API, but there's just some basic usage here. Get Marco public string Marco hello. Okay, so super basic health API here, and I also want to make this match that. Make this match that. I'm going to delete some of these pre-built-in classes. I'm just sort of deleting some of the stuff that comes along with these automatically. And let's go ahead and run this and take a look at our Marco Polo. Okay, so we've got a Marco, try it out, execute, we've got a Polo. Okay, cool. So our API does work. It's not what we're focusing on, but we have to have a project here in order to work on some stuff. So make a project, and let's go ahead and commit it. Cool. All right, we've got a project here. Very nice. All right, so the next thing I'm going to do is essentially get to work, but there's a lot of boilerplate stuff that you're going to do. So, for example, creating the unit test project would have been a boilerplate thing, and creating some of the models such that they match, the expectations here. I'm not going to sit here and program each of those things while you guys are watching me. So I will just do this. Let's go and close that. Do this. Replace and reopen. Don't know why that's open. Okay, so we can see the things that I just did, and it looks like a lot, but it's just boilerplate stuff, right? So we have an interface here, and this is going to be that very last step where we say estimate the year. So we've got this service interface that's going to be right there. We've got a paycheck line item, and you can sort of see that inside of our thing down here, that each line item will have like the date, the withholding, things like that. Actually, that is a paycheck, not a paycheck line item. The date, the withholding, and then line items, and then the line items will have the hours worked on that line, the hourly rate, the description, the total paid, things like that. We have a payroll service. Nothing is implemented in this. This is what we're going to call the functional core, but we'll get into that. We've got this payroll service. This interface is being implemented, but throwing a not implemented exception, and so on and so on, so on and so forth. So let's go ahead and say, well, I can actually show you guys the API now. So the API now, the Marco Polo still works fine, but we also have this estimate client ID, and this is going to be what the end goal is. Once we get through all of the testing and all of the test-driven development, essentially. So right now, what we're going to say is, if we try to send this in, which is going to ask for what client are they working for, and in order to ask what client we're asking that because we need to know what rate are we billing the client so that we can calculate what rate we're going to be giving to the consultant, and also some other things about the client. And we're also asking them what their monthly benefits are. So if we're expecting an employee's monthly benefits, healthcare and all that stuff to be like $600 a month, we need to put that in here so that we can better calculate what their annual is going to be. So this is just an example. And we're returning back a 418 because nothing's implemented yet, or it's off, or it's circuit breakered, or feature gated, or whatever it is. 418 means I'm a little teapot, or I'm a teapot. And a lot of people use that just to say this is currently off, or not implemented, or not finished, something like that. So let's go ahead and commit this. Core contracts finished, created. Okay, so we now have Marco. Yeah, we now have just the contracts here. We just have a shell of an application, not just a shell, weather detector. What was it called? We don't just have that shell. We now have just a shell application that also has our contracts in it that we're expecting for our domain. Okay, so a lot of boilerplate stuff that I just skipped over, and probably delete that one out of here. Okay, so let's get into some unit testing. We're going to start with, we have all these calculations that we know we're going to have to do, and we're going to have to get these right because these are the business rules. This is the business logic that we need to put into our domain, and we need to make sure that all of these things work before we compose our application together and use that estimate the year for estimating the year. We can't estimate the year unless we can do each of these calculations. And of course, I'm not going to write line for line each bit of code. So let me start. I'm going to pull up on here, bam, bam, bam. Okay, let's start by writing a test, or by copy pasting a test in this case. All right, so we've got this theory here, and we're saying that in order to figure out the rate after the client withholding, that is, this isn't the rate that we're charging the client, it's the rate that we're paying to our contractors. So it's that client rate after we do that, like the 10% withholding. We're going to need to know what the client rate is, like $100 an hour, $200 an hour, or something like that. we're going to have to know what percent we're withholding, which could be 10%, 0%, 50%. And I'll just point this out right now. In XUnit, or actually in attributes in C#, you can't pass a decimal as a constant. So in XUnit, you can't pass decimal as a field here. So I'm passing it as a string, and then I'm doing this this conversion right here. So I've got the client's rate, where we're withholding the examples, the expected string, and then that's converted to the expected. So this test obviously fails. I don't have to run it and show that it fails, but we're going to have to implement this get the rate after the client withholding. We're going to pass in the rate, and the withholding, and we're expecting back, for example, if we're charging the client $100 an hour and we're withholding 10%, we're expecting to be our employee/contractor rate would be $90 an hour. So let's implement that by going over here. And that's not right. There we go. All right, there we go. So I'm going to point out one pattern that I use so that it's not confusing, and also just to point it out because some people call me out on it. I like to, whenever I say functional core imperative shell, I like to use the partial classes in C#. Not everyone likes that. Some people like to use helper classes or something else. I like to say that this partial part of the payroll service is the part that implements the interface. It's the imperative shell. We're going to be composing all the functionality, all of the impure calls and everything within this method, and this is the method that's defined inside the interface. This is the imperative shell part of this class. And the functional core part of this class is the same name. It's a partial class, and it has only the pure. These things can't and or shouldn't be hitting the private fields, the dependencies of the service. These are static. They're pure. This is like the functional core portion. So I'll point that pattern out that I'm using right here. So we've got rate after client withholding. We've got some tests, and we can say that based on our acceptance criteria, or the additional details anyway, we can say, bam, these tests pass. We've written the test, we've written some code, this stuff passes. So what I'm demonstrating here is that what we're testing, these unit tests are testing against functional code. I wouldn't ever assert that literally it's a law that you're testing functional code. But that's essentially the pattern that you end up seeing whenever you're doing unit testing in a test-driven development way. So you say, I've got this business logic, I'm going to write these tests, these are things I'm expecting, and what you end up writing is something like functional code. Because right now we're not going to purposely take the extra time to go create databases and tables and put data in tables and then do integration tests and like connect to the database and all sort of stuff, and then mock it out and then purposely mock it out inside of our unit tests. We're just saying, let's just write the functional code that fulfills the requirements of this test. Cool, so that's one thing that we are going to test. And let's go ahead and just grab another one here as another example. Bam, bam. Okay, so we also need to test the weekly pay. So the weekly pay for a client is if we have a contractor going to a client and the client is and they work 40 hours for the week. This is a weekly pay, and the rate that we're charging, the rate that we're paying the contractor is this, and this is what we're expecting to come back. So for the weekly pay, here's the hours. Here's it has to be decimal parsed because of the way that the testing works. So here's the rate. Here's the hours, and we should be getting back something. It's not implemented yet, so let's go ahead and implement it. Bam, bam, bam. I'm not going to go through all of these, but I'm just sort of, doing a little bit of it so we get the idea. Okay, so payroll service.client weekly pay. Here's the hours that they're working, which would be like 40 hours. Here's the rate that we're paying the contractor, which is like $100 an hour. And so we're expecting them to be paid $4,000. It's not really that big of a deal. It's the same for all of these. And there's some examples. We should not be paying them a negative rate, and we should not be allowing them to say, I worked negative hours. So here's all the tests. I run all the tests, and all's good. I'm going to put the rest of the tests in here. They just keep following the same pattern. You just call a functional method, you have some assertions about what you're expecting, and you get back what you're expecting. It's purely functional. It all looks really good. So let me come over here to the payroll service, do the implementation portion of this. And so we've got the same thing. This pattern that we're following, if you watch any of my other videos, then you may get this, but if not, then I'll go ahead and point it out right now. So we're using the maybe monad for all of these functional calls. And the reason we're doing that is because we don't want to say, if there was a problem and the hours weren't what we're expecting. If you don't know, this is called design by contract, where you have all you're checking all of the parameters coming in at the top, and if they're not within the valid range, or it's nothing that you're expecting, then you throw an exception or you return null. Usually you throw an exception in design by contract, or you return null. But in this case, we're using the maybe monad, so we're saying maybe.none. So if it's something that we don't like, we're going to return this maybe monad.none, and we're going to say that value is invalid. Same thing if the rate was less than 0, that value is invalid. And then some basic logic, if the hours are less than or equal to 40, then just return 40 times, just return whatever those hours are times the rate. Otherwise, if it drops through that and the hours are greater than 40, then we're going to do 40 plus hours minus 40 times 2, which will give us the overtime hours doubled, and then multiply that whole thing by the rate. So there we go. So we've got some tests in here, and I'm trying to get through the idea of what do we test pretty quickly. There we go. Got a bunch of tests. We got a whole bunch of logic here. So at this point, we fulfilled creating all of these calculations. And what we have accomplished, let's go ahead and do this. Finish functional core. Commit all. Yeah, partial classes are underrated. I think they're underrated because they have such a taboo against them, because they're thought of as only being things that are used in generated code, or they're thought of as things that are overused and done as sort of a bad replacement for helper classes. But if you're using them following an actual pattern called functional core or imperative shell, then I like them. But not everyone likes them, so it's just a personal preference. I don't force anyone to do that. Okay, so we've got the functional core finished. Now, if we were to run this and hit our endpoint, we would still be getting back that 418 because we haven't created that yet. So let's go ahead and just walk through a very basic implementation so that we can hit this endpoint and show that this all works. But you'll notice when I do this implementation that I'm not writing tests right now, specifically unit tests. In a test-driven development environment, in a great system where you have great processes, you're doing test-driven development, a lot of shift-left mentality, you have the SDET or the QA person, or maybe even the developer, in a different system, such as Postman or something like that, writing these tests that are going to hit this endpoint. That's why early on, which was a couple commits ago, we created this controller. We have this controller, we have the contracts here, but we haven't done the implementation yet because that's not really our concern. Our concern is the test-driven development, the unit testing, the functional core. That's like, let's take a couple hours to work on that thing. But in order to enable the SDETs or the QA or some other developer to write those tests in Postman, we can instantly create these contracts and have them return 418s. That way they can at least have endpoints that they can hit, and they can get back 418s and say, okay, my code can at least hit these things. Creating these contracts up front this is going to annoy me. Delete that. It's gonna come back here in a second anyway. So at least having those contracts for them will allow them to do their work while you're also doing your work, and they can do their sort of test-driven development, creating all those tests against the API while you're doing the functional core. And then later on, you're going to get around to doing this, implementing the API, implementing the imperative shell, interface implementation here. You're going to get around to doing that, but right now you're focused on the functional core. So yeah, we've already created all this shell of this contract stuff for them, and I'm now going to start implementing them without writing tests, without writing unit tests. The assumption or the hope is that those tests already exist. Someone wrote them in Postman or something, and if not, then maybe that's going to be your job. So when you get to this point, you're like, okay, well, no one else is doing this. We don't have an SDET, or QA doesn't do those things. It's the developer's job. So maybe you go write those tests somewhere else in Postman. But those aren't called unit tests at that point. Those would be called system tests or acceptance tests or some form of integration test. But what we're going to do now is go ahead and do the implementation here as if someone had gone and written those tests for us. Again, they're not unit tests. So let's go to here. I'm going to start with, I'm not going to just copy paste this whole thing in. I want to sort of focus on something a little bit here. It occurs to me that client isn't a perfect name, but because it could mean like client server. But in this case, we're talking about like the client, our customer. Customer would probably be a better one. So we're going to call a repository. That instantly shows us that what we're implementing here is an impure method. We're calling out to a repository, which is hitting a database. And yes, if we wanted to unit test this particular method here, we could mock out the repository. But assuming we just did something like this, return new list paycheck model, something like that. So assuming we didn't have much in here, maybe there's another line or two between here. There's nothing to unit test here. This is essentially saying call a repository. Maybe there's unit tests inside of the data layer. I don't want it to preview. Maybe there's unit tests inside the data layer, or maybe there's integration tests against the data layer. So whatever that is, that stuff's being tested by itself. We don't need to duplicate those tests. If all we're doing is saying get that stuff and then return something, there's no conditional transformation here. Conditions can exist without transformation. Transformations can exist without conditions. There's no conditional transformation going on here, so it's not really worth it to unit test. The reason I say that is because if your test, if you're, for example, inputting, if you're doing an add method, you have add into number 1, add into number 2, or part 1, part 2, and then you return, part 1 plus part 2. If your test also says, create part 1, which is 867, and create part 2, which is 345, and then you pass those into your method, and then in your unit test, you're adding those two together and then asserting that they're the same. If your test ends up looking exactly like your code, then there's no value to your unit test. And that's what ends up happening. Something along those lines ends up happening if you're testing code that is not doing conditional transformations. If it's just transformations, or it's just conditions like, if it's just testing purely this condition right here, that it's a guard clause or designed by contract, then it's not adding any value to your test. Of course, you want to test against these things, but if that's all your method is doing, then it's not adding any value. This one's doing conditions and it's doing transformations. Okay, so here we have the client and we're saying repo.get client. I don't want to break down this whole thing on how to do it what I'm going to say is the traditional way, or even possibly the gross way. But let me show you an example of what this looks like the traditional way. I did indeed write this program 3 times. So the traditional way, we'd say repo.get client. We're not using the maybe monad here. We're getting back the client details, which is like their rate and what is it? Their rate and what they require you to withhold for their projects, something like that. But if the client equals null, then throw an exception, return null. A lot of times, this looks very robotic or repeatable, but in reality, like this one would be wrapped in a try-catch. And you might imagine there would be another repo call either at the bottom to save something or in the middle to get something else based on a previous thing. So there would be a couple repo calls in here. They might not all literally check for null and return null, but it'll be something like that. You want to make sure that you're checking those things. So this is what it'll end up looking like. Get the client, check for their rate, the employee or contractor's rate after the client withholding, check for what we pay them weekly, get a list of how many paydays there are in the year, generate paychecks, so all 52 paychecks for the year, and then add the withholding return at the end. This is essentially what traditional code will look like. But instead of doing that, we're going to say, bam, So we're going to compose this method out of maybe monads. And if you noticed before you had, I shouldn't have closed it, I should have pointed out the whole point of what I was talking about. So if you notice, these are what I was saying is called a guard clause. So we're not doing a conditional transformation, we're doing a conditionally throw an exception or conditionally return null. We're essentially saying conditionally don't keep going, because here there's a whole bunch of functional logic and transformations in here. So we're saying conditionally don't keep going. This is called a guard clause. If this was a condition and then I said 5 plus 5 or something in here, or ID plus year or something, then that would be a conditional transformation. But this is saying conditionally cut out. We're done. Now there are conditional transformations inside of each of these functional methods. But the good thing is, as you saw in the project, we have 30 tests. We have a whole bunch of tests that are each testing all of the conditional transformations inside of these functional methods. So writing a unit test against this would only be bringing the non-value, the zero value of testing conditional transformations. But we're already testing like if this returns null or if this returns none, maybe dot none. We have all those tests in there. So retesting it here is there's no added value to that. So no need to write unit tests against this. That is what it is almost literally doing here. So here, when we say dot bind, yay Google. Okay, so here where it says dot bind, what that's saying is over here inside of our monads, instead of returning null, return maybe dot none here. And instead of, and then actually this is technically returning maybe dot sum. It's just automatically converted. So let's just put it back. Okay. So here we're returning maybe dot sum. It's boxing it into this maybe right here. Here we're returning maybe dot none. So what that bind is doing automatically internally, this is a built-in thing to every monad. It's saying once this get client returns, and again this get client is also returning a maybe. When this get client returns, if it had an exception or a bad value or whatever it was that told it to not to return a maybe dot none. So if that happens, if it returns a maybe dot none because something bad, something unexpected, or something negative happened inside of it, then what this dot bind does is it says the something bad happened, so just return back. It's just like previously we were saying, if the thing equals null, return null. But the good thing is this isn't returning null. This is saying the prior thing, this get client, we're going to bind on it. So we're saying if the bad thing happens, just cut out right here. We're done. And just return back a maybe. That means that this will return back with the information from that failed get client. It'll say, couldn't find the thing with that ID, or threw an exception, couldn't connect to the database. Whatever it is, this dot bind will cut it out. But if it returned a maybe dot sum, so a non-null value, if it returns something that was expected, that we're happy with, then it says let's continue on. And so we're just composing it saying call this method to get the rate after client withholding, which results in this rate if it was successful. If it was not successful, it'll cut out. Call this client weekly pay to figure out what the weekly pay is, which will result in this client pay object right here. If not, it'll cut out. And then, so we're just composing saying do these things, and then end with, after this generate paychecks, which is just generating a list of all 52 paychecks, we have these paychecks, and then we're going to call this last thing right here. So this is now composed. You can think of this exactly the same as all of those guard clauses, all those if it's null, return whatever, or even the some try catches. That's what this bind is doing. So we've now composed this method. We don't need to unit test this method because, like I said, there's a bunch of unit tests. I mean, this get client inside the repo will have its own unit test or integration test or whatever to the side. So we trust that is fully tested all by itself. This is definitely fully tested. This is definitely fully tested. All of these things are definitely fully tested. The whole functional core has unit tests written against it. So we don't have to test this estimate year because there'd be no extra value added to it. So let's go ahead and pop back up to the controller. And the controller needs an implementation. needs to be async. Okay, so the controller is saying call that estimate year. And then when it gets that estimate year, it's saying .match, which is not necessarily part of every monadic, maybe monad implementation. But this is very similar to bind, except that there's a little bit more functionality that I'm not going to during this video. But what it's doing in this case is it's pulling the result out. This is the result, which is a list of paychecks. That's what that estimate year returned back. And it's saying, let's just do a DTE or an ACL. It's an anti-corruption layer where we're converting away from that model and converting it into this DTO that we want. This is the DTO. This is the model that they want us to return back to the front end or the caller so that they have all the information that they need. They don't just want a list of raw paychecks and then they have to do like calculations themselves, or it's really ugly to them. So all we're doing here is a data transformation to transform the results of that list of paychecks into the paychecks here. So data transformations don't necessarily need to be unit tested. I would never say that you shouldn't unit test them, but we get back to that same issue that I was talking about before, where every single change you make to the data transformation, you then also have to make to the unit test, and they end up looking identical to each other. So there's no value to it. There is value to testing it. So a lot of people who are watching this saying you should be testing everything because every change should possibly end up in breaking your system, and that's true. But I'm saying you don't have to unit test them. Unit testing should be testing your functional logic. This code right here specifically does not need to be unit tested. The integration tests from this change, the integration tests that are being written by the SDET in Postman or something, or by QA, or by you prior to doing this project, those integration tests will make sure that when you call this method, you're getting back the exact thing that you want. So the transformations will be correct in that case if you're getting back the exact thing that you want. And the reason we're doing this transformation, just so you know, is because there is no, this calculated field of total paid is not part of the list of paycheck model. A list of paychecks is just a list of paychecks. So this is a calculated field. So inside of our DTO, we're doing this calculation where we sum up those total paid of those line items. And we're also summing up all of the withholdings. So every week that we did a paycheck, we withheld $250 or whatever their weekly from their benefits, their healthcare benefits, whatever that was broken down weekly. So we're going to go ahead and sum that up for them also. Just go ahead and run this and see where we're at for now. Okay. So client ID 100, whatever client that happens to be. Let's say we have $600 in monthly benefits. We hit execute. We come down here, and we now have 52 paychecks. We got paid a total of $228,800, and we had a withholding of all of our benefits of the year was like $72.90. And every paycheck essentially we're working for one client. This contractor is working for one client, so essentially got paid $4,000 a week for their client invoice. But this last one, they had their client invoice plus also an extra $20,800, which is returning that 10% withholding that was happening to them. All right, so we've got a lot of this. Okay, another thing that you're not supposed to be unit testing is estimate payroll in general. Previously, I was just talking about this data transformation portion. One second. Yeah, this video will be available for later. These videos are recorded. They're on YouTube, on our YouTube channel. So ping me in Slack if you want to know more about our YouTube channel. Or actually, it's called GenGuild, youtube.com/GenGuild. There you go. So yeah, you should be able to watch this later. Okay, so previously I was talking about you don't necessarily need to unit test data transformations because the tests are going to look identical to the data transformations. It's super boilerplate. But more generally speaking, you do not need to unit test this API endpoint because this API endpoint is doing nothing more than calling this and doing a data transformation. It's calling this method, which is doing nothing more than a bunch of binds, which are guard clauses, and they're either calling into these repos, which those things will have their own integration tests, or they're calling into these functional things. There's no value. There's no value in testing web API, unit testing web API endpoints. Again, integration testing, system testing, acceptance testing, all those things are going to end up covering those things. But no need to write unit tests. So the whole point of this talk is to say your unit test should be super simple. You call a functional method. It doesn't have to be called functional. It doesn't have, you call it whatever you want. But it's a pure method that you don't have to mock things out. It's doing business logic, and then you're asserting it better equal what I expect. And that's I think a lot of people are shy away from unit testing because either A, their code is really complex, they're trying to unit test web API and spin up web API and get app settings in there and then test against the, and then mock out the database, or, it becomes really complex. Or either that their code is really complex like that and they're not separating their functional core from their imperative shell, or maybe they're not doing unit testing because there is nothing to unit test. In the whole world of no code or CRUD microservices, perhaps your microservice literally is just an API endpoint saying create a model. So they pass a model, a JSON model, it serializes, it deserializes into a model, passes it to Entity Framework. Entity Framework saves it in a database and returns you back the ID. And there's no business logic in there. You're literally doing nothing with it. So if your API service is literally doing nothing as far as business logic goes, then you wouldn't have unit tests. And that's perfectly fine if you just have a CRUD or a no-code style web API microservice and it's just doing stuff with the framework, stuff that's built into the framework and passing data between a caller through some sort of a firewall or an API gateway and then onto the database and sending things back and forth. If that's all it is just a shell, then maybe you don't need unit tests. But if you have any business logic at all, any of those weird transformations, not just regular data transformations in some sort of an ACL, but some sort of transformations that require you to have functional logic like this, then this is where you're going to be doing unit testing. And you shouldn't shy away from unit testing. This is how you do unit testing. And this is how you do test-driven development. You write tests, you write functional code, and then when your functional code is done, I guess this is a really important thing to say, once you have your functional code here in your functional core, you don't then say, oh yeah, but in order for me to get the client rate, I need to hit the database, and that means that right here I'm going to do var client or client rate equals repo.getClient. You don't do that here. You don't go into your functional code and dirty it up. You don't go in there and put impure methods and impure calls into there. You keep your code functional, and what you do is you create an imperative shell, and this is where your imperative code goes that does all your dirty calls and it composes all your functionality, and this is where you end up putting your dirty compositions. Your dirty comps sounds good to me. And so you don't need to test this. You don't need to test web API. You don't need to test your startup.cs or your dependency injection. That's not what you unit test. Those things will be tested by integration tests, system tests, acceptance tests, things like that.